exam. Now the recording is in progress. One thing I want to point out quickly, this was 2 semesters ago for the OPL exam. And the content is essentially almost similar. The extra credit is a little bit unique in a sense that toward the end of that class, I was covering things like compiler optimization because we have time. And the extra credit is based on those lectures, so don't mind those things. We did not cover it in this class at all, so that's not part of the exam. One thing to notice is 48-hour exam. And I've been talking to several of you after the class. There's a high chance that I'm going to extend our exam to be getting close to 48 hours without making the exam longer, because multiple of you have exams on the 3rd and the 4th, and also projects due. And I think basically tons of other assignments and projects due around that time. So I think it's okay to extend it a little bit. I kind of treat these exams as like extended short assignment, regardless, because it's not live in person, right? So one of the thing is that, by the way, the reason I look that way is because that's where the screen is. So I would face that way and come back here a little bit. Know that there are 48 hours here by default, which means that you are going to get more problems. In your exam, there will not be as many problems. Otherwise, the rest looks similar to your midterm exam in terms of the length and the policy. The first question has to do with the, I guess, the assignment called read aloud, right? So in the OPL assignment, there's a question called read aloud where what we ask you to do is to use dependency injection to essentially convert integer input into string based on how you would like to read it, right? For these particular exam question, what we are asking you to do is something pretty simple, actually. Extend that homework, but now let's do a different version of read aloud. The first version basically is called mirror read aloud, right? Where this should be like 3 points. The input, whatever the input is, give them the same this exact same thing as an output. You read it the same way, right? The second version is called counting read aloud, where that's the way you define it in the homework. This is basically to test whether you did the assignment or not. If you haven't done it, this is the time to do it. The third part is the version where if you have the input, you read aloud in any order, in any order randomly. Basically, it's called unordered read aloud. And the fourth version is called stutter read aloud, which by no means I'm not trying to make fun of people who have stuttering. It is a really, really bad thing to happen. But for this particular question, if the input looks like this, 1, 1, 1, 2, 3, 4, 4, 5, right? The stutter read aloud will take in for any number that has only one element, in this case 2, 3, and 5. You then read 2, 2, 3, 3, and 5, 5. So in this case, the output should be 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, because there are only ones of the 2, ones of the 3, and ones of the 5. So you need to read it twice. So that's the first question. And here is how you can implement it, right? Mirror read aloud is simple. By the way, this is one of the submission from your senior. And I actually like this this summation quite a lot because the way this is really well commented. So basically mirror, read aloud, simple, return the same thing. These should be 3 points. Counting read aloud also should be pretty much 3 points for these guys because it's in the homework, right? So basically the way you can do this is you go through the list by looking at the helper function. You have the list as an input and you look at the previous element and then you return a list. And then you do pattern matching. If you match where the list is not empty, you check if the previous number is the same as V. It means that you still count, right? Basically, you still keep counting. Copy is a number of how many times this number appear. So let's say it's 11111. You would then take 1, previous is 1. So you are counting, there'll be 5 of the ones, right? So at the end of the day, you can return the list of number of copies for each element that you see. And you go through the list that way. Right? And order read aloud, basically, this is another 3 points one where you can shuffle the list by using a random built-in function. So this is like, if you actually understand how scalar works, this should be really easy. You then look, okay, if I have a list, how do I randomly shuffle? And if you look it up, because this is a takeover exam, you know you can do this. The last one is the one that's probably not really tricky, to be honest, but it's kind of like equally tricky as the homework version. But if you did the homework, you should be able to do this, study read aloud. And the way you can proceed through is, by the way, if any of you who attend this session have a question, feel free to type in the question too. I will, one thing for sure, because I'm going to primarily post this on the video. So I will repeat the question so that people who watch it later can understand what are the questions that get asked. For the last part, basically you go through the list as well and use, again, previous and number of copies. If copy is greater than 1, you don't do anything. You just basically maintain the same list. If the copies is 1, which is the case where you need to create a new element, right? So if previous is different than the current elements and copy is 1, then you need to double the elements. You add 1 more elements to the list, and that's it. And the rest are the dependency injection part, where you do the override read aloud, and that's all. So that's all for the first questions. Anything that you have in mind that would like to ask for these particular questions before I move on to the second question? By the way, again, will not be posting this on the files on Canvas because I'm not sure it's a good idea to let everyone download it. But you can take a look at this. Let me zoom it in a little bit more. So if you want to take a look and you want to pause the screen to read the question, you have it here. So I'll let you read it. And I think that should be enough time for you to, yes. Yeah, so that's why I said it was the last semester assignment. This semester I cut a few questions out. So it's not in this term. So you can guess that if I have something like this, I'll making sure that it's more well defined for your test. Right? Basically, I'll make sure that you understand what's going on. By the way, the question was read aloud is not in assignment 3 this term, right? Nope, it's not in assignment 3 of this term. So let me proceed to the second question. The question is really simple. Do quicksort in Scala. The reason why I asked everyone for the last previous semester to do this is we went through a quicksort in Rust, and this is actually right before COVID hit. So I was doing the quick sort on the board, right? At MUIC on campus, and there was quite a because it's in person, we do it on a whiteboard. There was like a great discussion going on. So I'm like, yeah, sure. I think it's probably a good time to ask you all to do the same thing in Scala, right? So uh, in this case, basically, I asked the students to, hey, you should now be able to implement quicksort in Scala, uh, use future, and implement a function called quicksort. And it should be able to take any ordered list uh, and provide a sorted list. Right, so this should be pretty relatively simple. And here is the solution again by the same students. From P-Funk, if you were wondering. And again, thanks so much for him for having such a nice brief. It's brief enough for the comments that I can show it on the screen, and it's clear enough on okay what the line is doing. Basically, and this particular answer is really interesting in a sense that for those of you who are doing the project that you want to do sorting, right? If you want to do sorting, the projects I already got one. Well, I think a few questions already about like, hey, in many cases when you look up Google and people will say, okay, if the number of elements is small, doing quicksort in parallel is slower. And the answer is yes, because the way you split and join things, the work required to split and join outweigh the benefit when the array is small. So what you have here is he actually checked the length first. If the length is smaller, you sort with the sequential version, basically, without using the future. And over here, how you define it is you have a list, right? And basically, you need to make sure you have this. You make sure elements is an order of list, right? And from that point, basically you define the pivot. What is a pivot? If you look at quicksort, pivot is that one element where you are going to compare every single thing in that array. If it's less than the pivot, you sort them to the left array. If it's greater, you put them in the right bucket. Basically, left bucket will be less than the pivot. Right bucket will be higher or greater than the pivot. After you're done, you recursively do quicksort on the left bucket and the right bucket. After you finish all this, everything be sorted. Okay, so quicksort recap done. First of all, you find the pivot. How do you find the pivot? Use random RNG over here, right? Next int. Make sure you put a ceiling on the length of the list. Otherwise, you pick a pivot that's further away from the list, and this is odd. Basically, you find then you create right, using future create a list of elements for the left bucket. Right? The left bucket, how do you do it? You use a filter, list.filter, right? You filter out any components in the list that's less than X. I mean, that's less than pivot. X is an input. So this is a function. Input is X. If you compare X and pivot and it happen to be less than 0 or less than, you use flat map to map to basically the future version of this sequence, right? Then another bucket is the elements that's equal in terms of the value to the pivot. That will be in the second bucket. Same techniques using filter, but now it's equal to 0. Then the elements that are greater than, you need to again concurrently call right the same function using filter. Filter compare to pivots. If it's greater than 0, you put in Yeah. So the question is for your batch. That's a great question. For your batch, you're mostly focused on parallelization with Rust. I agree. And you don't recall using futures in exercise and assignments. I also agree. And that's unique for your batch, and I'm aware of that. So I guess my hint is don't worry too much about this, but then worry about the Rust part. Is that okay? If you know what I mean, basically. I guess, do you understand what I'm trying to say or what I'm hinting at here? Okay, cool. Yeah. Basically, I'm hinting at if I'm asking you to do something in parallel, it's likely to be in Rust. Otherwise, I would need to explain in detail how I plan for you to do it. All right. Uh, so, but I guess that's also good. It's also good that I showed this example because this is how you can also use future for parallelizing things. Then you use await. The await function that if everyone might be recall, hey, await means that you're gonna wait for a while for the future to arrive. Basically, once you're done, right, you notice that duration here you need to put in infinite. Basically, because you know that you get everything, right? So once everything is over, you fold the list together and then return the resulting list. So that's it for how you can get quicksort implemented in Scala. Again, hint. I actually not sure what I'm gonna have for the exam, but I can argue the same, but now you do this in Rust, right? So that can be potentially something that happen on your exam. And I don't, to be honest, because I haven't really come up with what I'm gonna put in for the questions yet. Everything is possible, but I'll make sure it's fair for your batch because we focus on way more on Rust and parallel programming. All right. So that's for the second question. The third question, again, this kind of required the prior knowledge from your earlier midterm. Basically, on a midterm, I asked the student. Obviously, I asked students to implement Huffman encoding. Basically, what I did was I have a question that I break down. How do you do Huffman encoding and ask you to do four things. Each of the things are essentially building a tree, counting letters, building a priority queue, and only insertion, basically priority queue insertion and remove, and then putting everything together. And actually, every student, all the students did pretty well for that particular question, right? So I'm like, okay, yeah. One thing that we haven't covered for the midterm is parallel programming. So in this case, I took the midterm question. I inject the fact that, hey, these two functions can be done in parallel. So, or actually not done in parallel. For I think, yeah. So both of them can be done in parallel, counting the letters and the insertion in priority queue. So in this question, I asked them, okay, parallelize them in Rust. The first one is basically parsing the data. The input data is a sentence in human language. The task is to count how many of the alphabet do you see. This sentence might have two A's, then you say, okay, A, that's two A's, five C's, one B, one Q, for example, and the rest are zero, right? So that's the only thing you have to do for the first task. And the second half is a priority queue where you do an insertion to the priority queue. And then I say, I say, to prioritize this process, you can find the correct location to be inserted in Trello by going through your list. You can sequentially write the resulting vector serially because I would like to allow the student to use mutable because it's 24-hour exam. I don't want everyone to think in like put in the functional programming hats and make sure everything is immutable. Over here, I care more about hey, let's try your best at making things immutable. But the writing part, when you write the resulting vector, you can use mutable, MUT, basically mutable. And then show the work and depth of your implementation for both questions. This is likely the I guess I would say that this is a killer question for the exam, and I kind of designed it that way. So don't be too surprised on hey, this sounds hard, right? There might be some question. Basically, your strategy. Let me tell you this more like a story, right? One thing I always try to do for all the exam that I'm doing when I'm taking an exam as a student, I'm actually going through the exam first, trying to make sure I know how much time I'm going to spend on each of the question, and then do it in a shorter job first manner. I go to the question I know I can finish it quickly first, followed by the ones that take more and more time. Because otherwise, if you see this question is like the third question and you spend too much time on it, you have less time to work the fourth and the fifth question, which might be easier, right? So here is a solution for happen encoding. This is a part that count the character, right? Counting character is not too bad actually, because what you can do is to go through the stream, basically go through the string, right? You have a string inputs here that are string sequence, and you return a vector that maps, basically a vector of pair. The pair takes in character and integer. Character is A, B, C, D, E, F, G. Integer will be how many times A occur in my string, how many times D occurs in my string. And yes, so there was a question, will this session be uploaded on YouTube? Yes, it will be. My intention I was intending to do this recording on the side because we don't have enough slot for that. But since it's on Friday anyway, so I told everyone, hey, you can join if you want. But this will definitely be uploaded to YouTube. Usually WebEx will have the video ready towards the end of the day, usually within 24 hours. After that is up, I'm gonna put it on YouTube channel so everyone can take a look at the question and the solution. All right. So let's go back to here. So basically there are two things that you need to figure out here. So first of all, how to count the character. Simple, right? You can use Hashmap. I never say you can't use X and Y and Z. So what you can do is, okay, one way you can count characters, you can use a map, right? A map fits perfectly because a map provides you a relationship between a character and an integer. And every time you see an integer, you just count one more. So you go to the string, right? Basically, you can go through your string and increment the map, right? And then what we can do here is we have a string and we create a hash map. So this is in Rust. So you can use C hash map is a built-in library that allows you to use hash maps. What is a hash map? Is a map that use hashing. Not sure if I want to go into more detail without burning the time for the slot here, but it's fast unless you have a lot of collision for the map key, for the key in the map. Child count util is basically the utility function that allows you to fork. Basically, you look at the list and do parallel lookup across your string to see what's the alphabet, what's the alphabet, what's the alphabet, what's the alphabet. What we can do here is to parallelize them, right? So over here, you want to be able to insert to your hash map concurrently. Basically, you look up, oh, that's a letter A. I want to insert letter A to my map. I want to insert them concurrently. Basically, once you see a letter, you then call upsert, which is insert and update, right? This allows you to do atomic insert and update. What do I mean by atomic insert and update? You do the update and insert at the same time in one single operation. This allows you to do it safely. What does the function do? It takes in count, which is the input. Again, double bar over here means that I want to do this in parallel. The function basically take in counts and increment it by 1. I see the letter, I count it by 1. Right? The second part of this is, so this is basically sequential part. Again, similar logic to quicksort. If the component is too small, you do it sequentially because the work done to parallelize things is basically too much. It's faster to do it serially. If not, you split the string into half, left and right, fork, do the count for each of the half, then join. Right? Basically, this is recursively breaking down your string so that you finally ended up with enough letters that you can count sequentially. You count them sequentially, put that in the map, and then you join. After this function, you then have the hash map that is already counted. The rest is you basically convert the map to a vector, which is a vector of pair that consists of character and number. The problem here is it is actually this one. The reason why it's long is basically originally you have a hash map. You want to convert it to a pair. No, not a pair. A vector of pair, right? To do that conversion, you can do parallel iterator and then bridge to map. Basically, apply the map function. You have input k and v, key and value. You just map it to key and value. It's the same component, and you collect it so that it becomes a vector. This returns a vector, so you get a vector at the end, not the hash map. And that's all. It's basically iterate through the map, print it out into a vector. That's all. All right, so that's for character counting. Insert into priority queue. Okay, by the way, for the work and depth. So this is for this specific implementation. The depth work is obviously open, right? Basically, you go through your string and count. That's it for open. That's simple. Depth is something a little bit more unique because now over here you fork, join. So that's login. Insert to priority queue. Well, first of all, work is open, right? And the depth is login. You can basically now first do two things, basically. When you want to insert something to a priority queue, you need to know where exactly are you inserting. Priority queue is sorted, right? Priority queue is sorted. By the way, for those of you who haven't taken data structure, I know that. So if this is the case, I will tell you how this works. The previous version of OPL, everyone who take the class are all senior, so they're kind of like, I know data structure already, so that's why I don't have to like explain that in too much detail on the exam. I'm aware that there's also like I think sophomore taking this class, so some of you might not have taken data structure class. Some of you might be taking the algorithm exam also next week. So I'm aware of that fact. But the way parallel insertion for the priority queue works is, well, first of all, you need to find where you want to insert. And then, right, and then you copy the sequence to return, right? So here is a parallel find. Basically, you go to each element uh, at the, it's like the technique in parallel programming is kind of similar. You can do parallel for loop, parallel iteration, fork join. Over here again, search, right? If you want to search, fork join is your friends because you know that the elements that you are having is already sorted. So you can search in parallel. You go look to the left and look to the to the right. If it's matched, which is over here, okay? If it's matched, you search for the index on your smaller list, find that particular index, return it, which is here. You return the index. Once we have multiple candidate index, you find the maximum of L and R. I mean, this is basically your pick. You can use max of L and R. You can use the smaller of L. Over here, because it's priority queue, use max of L and R. Then parallel copy. Again here, concatenate two vectors by splitting them. Once we have enough of the split where each of the sequence is less than over here 2000 elements, you perform the copy by basically pushing the new elements into the list, right? Pushing elements into the list, then return. After you return, you concatenate the left and the right list. That's it. Basically, after you do these two functions, first you find the index on where you should perform the insertion. Over here, you perform the insertion by adding the elements into the correct index. For those of you who are wondering, how do I make something that supposed to be mutable immutable? This is how. You make a copy by inserting the new elements. This is similar to the question that many of you have in the assignment 3. Because over here, this is the way you do it in functional programming styles. You modify something, you make a copy, add whatever you want to add, return that new copy. All right. So this is how you can do insertion, which is again, you have a list, you insert something into the index, you have a new list, you return a new list. And over here, you notice there's no mutable here. Okay, so that's for the third question. The fourth question is the first question is more like a written question where we ask why linked list is bad in Rust, basically. Why what are the example list operations that becomes performance bottleneck or erroneous results? A few things can happen when you have lists in Rust. So that's a great question. So the question is, will a lot of finals questions directly rely on you finish the in-class exercise, homework, and midterm? Yes, for the in-class exercise. Yes, for the homework. And I mean, why not? These are the parts of your exercise, right? So, I mean, unless you want something like a completely new question, which I think is harder. Up to you, but I feel like if it's based on the in-class exercise or homework, you have something to build on. If it's totally new, it's going to be totally new, and it requires a little bit more time to process the question. So yeah, I think the answer is yes for the in-class exercise, yes for the homework, and no for the midterm. The reason why I said no, yes and no for the midterm, uh, the reason why I say that is because it's fair for me to expect the students to be able to finish the in-class exercise and homework, or at least read them, right? And these, when you see the same type of questions but extended, it allows you to like, oh, okay, this is the thing I've done earlier. All right, so for the linked list, the reason why linked list is not as good compared to vector is when you have to modify something in the linked list, you have to log everything, right? For the vector, you can actually kind of like partition them and modify them. That's one of the possible downside. Newton's method for square root. Basically, over here in class exercise, we ask you to do Newton method for square root in I think in the really early in class exercise, if I recall correctly, it's not the second one or the third one. And what we want you to do is to do the same thing, but in Rust. It's as simple as that, right? And how do you do it? This is really simple. Why? Because you already done this on Scala, so you apply the same thing. Good enough function using the same equation you develop through the in-class exercise. The improved function, which is gas minus f over f diff version of f, right? And then once the gas is good enough, you return the gas. I'm not even sure if I need to share this screen for any longer. It's really, really, really simple. Basically, f is going to be x squared minus y. Diff of that, x squared minus y, diff of that is 2 of x, 2 multiplied by x, right? That's all. So that's a solution. This question should be like easy, really easy to do. And I think everyone got the full credit for this. The last one, this is kind of like an enigma from the midterm from last OPL class. I was asking students to implement Ackermann function in two styles. The normal one, which is defined here, and the CPS one. And the CPS one is really, really annoying. I regret that. But since it's an enigma, everyone can remember this function. I asked everyone to now, okay, implement the same function, but make it as fast as possible in Rust. And the function is defined like this. Ackermann of mn is going to be n plus 1. If m is 0. If m is not 0, but n is 0, it's going to be m minus 1 and 1. If m is not 0, n is not 0, it's going to be m minus 1 and Ackermann of m and n minus 1. So see how there's like two, basically this is recursion in recursion, right? And Ackermann function is kind of known to be one of the fastest growing function. Ackermann of 5 and 4 will be like really large number. As some like Ackermann of something less than 10 is going to grow really quickly, and it would overflow long integer really quickly. And here is one of the implementation from a different student. So I think this is the fastest one that we have. So what we have here is memorization. So the techniques that these students use is memorizing Ackermann when you have different value of m for the first 3 m's. These cut the execution time by a lot because you can flatten the function into something based on just n. Ackermann of when m is 1, it's just n plus 2. If m is 2, it's 2n plus 3. And if n is 3, it's 2 to the power of n plus 3 minus 3. And then for n is 4, you do it normally. Actually, n is 4, you can still do power up to n times. Basically, power up to n times means that you are recursively going through power up 2, but you do it at n times. It's 2 to the 2 to the 2 to the 2 n times. And you might notice now why this is really fast growing. You do power of 2 to the 2 to the 2 to the 2 to the 2 n times. And the input is 2 and n plus 3 and then minus 3, right? If otherwise, you do it as defined by the function. The reason why this is really fast is because Ackermann function grow to the point that unsigned 64 overflow really quickly. In most cases, you're kind of stuck between m is 3 and 4. If you stuck between m is 3 and 4, you know that most of the time the function call can be flattened into much simpler function without recursive call, which is these 4 functions. If that's the case, why not? Right? So memorization over here in Rust turns out to be really fast for the Ackermann function because you know that your output will overflow 64-bit integer. If my output is maybe, I don't know, 256-bit integer, this implementation might be a little bit slower. And as you can see here, Ackermann 4 and 1 is already the maximum value of the short int, right? So if you look at Ackermann of say 5 and 2, it's really large. So that's it for all the last year exam. As I said earlier, so if you look at extra credit, we were talking about how compiler optimized your code a little bit during the free, like not free time, but like the extra time in the class, because over that semester we talked a lot about the programming language and the structure of programming language, and also things like these are things compiler can do, these are things compiler can optimize. So toward the end of the lecture, the semester, I'm basically going to, okay, if you look at compiler, these are basic things that they can do. Over here, this is from, I think, one of the example we have in class, and no one attempted. So during the class, I was trying to say, okay, there are a lot of things like this, a plus b, b plus a, they are the same thing. We can actually sort your variable here into a plus b, and you notice it's the same argument. You don't have to do the add, you can use the old value. Regardless of that, I think now we cover all the 5 questions. Anything you want to ask before we adjourn today? Now that there are actually audience. Otherwise, I'm gonna let you see the questions a little bit longer for the 5th question here, just so that you can take a look at the text, and on the recording, you can basically pause and read it. Now I'm gonna go through the 4th question and allow you to just basically read it and pause. All right, so I think that's it for the semester. Actually, I will see everyone on basically next week. I'll be online to answer your exam related clarification questions on Discord, like usual, and I will announce when the exam would be due again. Just once I figure out the time and how much time I should give all of you, probably 48 hours or 30 hours. I will let you know when the exam is due. It will be due on Saturday sometime, because I know that several of you are taking the algorithm exam on the 3rd, and I think another group of you will have exam on the 4th. So I think this gives enough flexibility for everyone. And I think that's it for the session here. So let me stop the recording. I'm gonna post it whenever it becomes available. Yeah, so the question is, will I be available for the question anytime between now and the exam? So if I let me double check my calendar because I think there are two more office hours, right? Yeah. Uh, Wait, no. Okay, so there will be office hour on the Monday, like the usual Monday slot. And then if you need me afterward, let me know. The reason why I cannot do the Thursday one because my university uh basically asking all the new faculty to attend the basically it's kind of like อบรมอาจารย์ใหม่สำหรับการสอนอะไรแบบเนี้ยครับคือ so basically I need to attend that because it's required to make sure all the new lecturer houses know how to basically develop all the coursework and everything, and it's kind of super delayed because of COVID. That's why it's right now, and it kind of like shift on my schedule next week. So I'll have office hour on Monday. If you still have question or if you would like to meet me afterward, let me know so I can make time for you. The time I make, like in all likelihood, it will be sometime in the evening because my day is miserable at the moment. Email works, Discord work. Email, to be honest, if you email me, you get faster response because I need to check my email every 5 minutes. And I check Discord every few days. That's the difference in the interval that I check the two platform. I'm so sorry. But yeah, if you need fast response, send me an email. If you need even faster response, send me either Google Hangout or Facebook chat. So, do you have my Gmail account? But email is fine. All right, so let me stop the recording.